Hi everyone, how are you? I hope you are doing well. In this video, we are gonna understand about the distributed system. I was given this assignment by uh, this Alchemist AI. So let's see what it is. So here is the repo. I have cloned it here, and here we can see we are given these two workers. It in this one it is of TypeScript, it is of API worker, and in here we have model which fetches the gamma model, okay, from internet. Okay, so let's start. Let's understand this. Okay, so first let's see. This is our code. This where I have pushed all the things which were required, which was like I have to give the infrastructure as code and so that it can install it. Let's talk about it later what all things I have installed. Let's first start by understanding what is this project, what we have to do. So here we were given two workers, so you know that uh, uh, we can run both of this in a single system, right? Like suppose we can use we can run a simple single process and that will fetch our model too and call the API. Like we can do this in a single process. So okay, so yeah, but what is the trade-off? Like, what would happen in that scenario? Like, we are using the same system for API call and running the model too. Like, suppose I have this system. My system is of 8 GB memory, right? So suppose I have this system uh, and I run the API to here and model to. Now suppose model we have a bigger model, so can it run it here? No, right? Like there is a scalability issues and we can't do anything much about it. And let's suppose another scenario like uh, there is API, like there are multiple hits coming, like a lot of requests coming to our API, and we are scaling it, right? And but along with that we are also copying the model which are coming, which is like a waste of resources, right? So we want to conserve it, so we want that we should run both of these workers in a separate system so that we can scale it horizontally or vertically what whenever we need using load balancer. Okay, so yeah, and another thing is that this is of node process and this is of Python process. Basically, we use models for the machine learning Python because it gives a lot of leverages and functions and modules which are not actually available with the node ones. So that is also, so we can create two virtual machines and we can run that. Yeah, okay, so and yeah, and let's see what we should talk next. So yeah, how so when if we put all of this in a single system, so what would happen is that a user would send request and model would uh, directly send response like this only. But what if we want authentication, like we want to put authentication or rate limiting or anything like this time? So it's totally exposed to publicly, like we can't do anything much about it. But what if we wanna authenticate, or like for the security purposes, or even if we wanna conjure our bill, like if anybody would keep on coming, so our AWS bill or our provider bill would keep on increasing, because it charges for the resources we are utilizing if keeps on scaling infinitely. So lots of resources we are gonna waste in that. So uh, these are the things, and yeah, we have already talked about all this. So yeah, let's move forward. Let's see. Yeah. So yeah, one another question is that if we are putting the two processes which needs each other in a different systems, then how are they are gonna talk with each other? By passing the by calling the procedures using RPC, remote procedure calls, over private subnet. Like suppose there is a VPC, virtual private network, and both of these virtual machines are here, right? So how they are gonna talk with to each other using RPC, remote procedure call? Like it can invoke a function into another one using RPC, like invoking function, which there are multiple ways to create that one, like we can see here also, like these functions like inference get response, the inference run response, or like these ones, how we are creating using I. There is a run time which we can use for that. Okay, so yeah, and let's move ahead. Now other thing is yeah, we have talked about this one. Now to the first yeah, let's explore the two workers, what they are. Okay, so first the caller worker, inference worker. Yeah, caller worker is basically the API. Caller worker is basically the API which will pass our requests, which will take our request and pass our request to the model, and then yeah, here you can see it will pass our request to the model and will get the response back, and it will give it back to the user only. Okay, and then what is the inference worker? Inference worker is which in which our model is running. Like it will first fetch the model from the internet, and then it would run it here. It would take our requests, and it would send it to the model, and model will give our response, which it will give back to the user via caller worker, right? Caller worker HTTP endpoint. Like why do we need a caller worker HTTP endpoint if we have already, like we can call directly by HTTP? Why do we need a worker for that, right? You might be thinking about that. So actually uh, our inter our workers don't understand the language of HTTP. It talk in a different language, like RPC, remote procedure calls only. So for that we need some translator, so it works like as a translators. It will translate our request into a form which worker can understand, and then so it will take that caller worker, and then it pass the request by converting it to the model worker, and uh, flow, you know, right? HTTP, you take the request, extract the message, and call the inference worker get response which it sends to the model, यानी कि inference worker which gives back our response, which is again get back sent to the user passing through the internet gateway. Okay, so let's understand. Yeah, these two got completed. So what is here? Suppose let's move to architecture, right? Yeah, here is the same architecture I have talked to you about. Internet like uh, user asks for suppose ask for their query using curl or whatever, using the web interface, UI interface, basically, but in the backend it will to go like in this form. Okay, so it will pass through the gateway, and then caller worker would translate it into a form that is understandable by the worker. So this will pass through the RPC, and then it will goes to the gamma model. Gamma model will query our uh, request, and then it will give our back our response, and it will again pass it in the opposite direction and get back to the user itself. Okay, now now before we are moving forward, let's understand a few things like process. What is a process? Anything running code is a process, right? So and every process has some ports and life cycle, memory, CPU usage. You can read about it in this one. I have written an article about it. Okay, so but here we are more very much consistent. We are what should I say? We are basically focused on the ports. Okay, why we are focused on the ports, I will tell you later. And our architecture is like, yeah, process A is talking to process B using the RPC. So yeah, so what is a port? Port is like suppose there is a building. Building is this RPC, this VPC model, and suppose in this virtual machine are the two apartments. So the apartment numbers of these two would be port. Like how they are gonna understand? Like yeah, they will recognize each other, right? So port is that apartment number, like a localhost 3000 and localhost 5000. So these number are the ports. So and different services. Okay. So what about our AI workers? Yeah. What are AI workers? So these are self-contained modular process in the AI engine. Like they are basically programmatical process which runs like it's a like robots working the factory. It is already programmed and done few jobs like uh, running our like we are invoking all those things, right? Like registering things on that. So it do all those things. And ISE, infrastructure and code, what does it do? It's do like suppose we are configuring the AWS, right? Like we are gonna configure the AWS for creating a VPC or virtual machine so that we can deploy our code to the internet. So mm, we will do manually all those things, right? But there is a issues like human can lead to some error which would create a lot of mess, like all those things, like and we also want a reproducible code, right? Reproducible code, like some we are creating this AWS the whole system like virtual machine and all that, and then another person, if we want, then that he also is able to reproduce the same uh, configuration. So how they can do, so they can use this system. Okay, and there are various ways to do this, like Terraform is one example, Ansible, or there are lots of them. So Terraform is a very famous one. We can use this create to create our configuration and then apply you and but also we need to configure our, we can also add many cloud providers like GCP, DigitalOcean, AWS, anything. Okay, and for AWS, yeah, if for AWS we need credentials like its a key value and yeah, like we need is AWS configure. We need to AWS configure and we need to get their security credentials, like which gives, I don't remember, like it gives the ID and the key. Yeah, these two things. Okay, so and then we can to Terraform apply. We can run the commands what they are, and then uh, also it can also help us, like we want to destroy it right now, like there are a lot of manual works in the AWS. Say we have created our whole of the infrastructures like VPC, route tables, or there subnets or everything like net gateways, which consumes a lots of which creates a lots of bill, it charges per hour, and then it also charges the bandwidth we have used to download. So yeah, it charges a lot, like it charged me $4. I wasn't aware about that I have created multiple net gateways. Okay, so because I was doing manually, but later on I am shifted to Terraform. So this is the benefit. It can also help you save your money. Yeah, so let's not waste time. Let's move ahead. What does it say? So we are gonna, let's again see what is the flow. User send our their query, their request, caller worker gets the request, change it in the form that workers can understand, then calls the inference caller worker trigger call Python worker inference gamma model generate response bubbles back, and going through all that and at the end it reaches the user. Same, I have shown it here in a different form using the mermaid writer editor. Okay, how the execution flow looks like. We will write the use the II command. It will read the configuration IL and then the WebSocket engine would start. But why we are using WebSocket? Why not HTTP? Because we not want persistent connection, right? Yeah, that. Okay, so we are using in a private setup locally for the WebSocket, so that both of the our virtual machine. I am not just talking about two virtual machines. We can create multiple virtual machines and they can talk to each other. Okay, so, but for this assignment we had needed to configure only two. Okay, so it loads the workers and then starts HTTP server 31 and worker registers functions. Yeah, so and these were the logs. I had actually seen this. I have right now destroyed all the AWS and I have also stopped. It would take a lot of time. We are actually here to understand the flow. I have uh, pasted the output in the README. You can see over there. Okay, so let's understand some of the jargons of the AWS real quick. Like VPC, what is a VPC? Like virtual private cloud. It's basically understand it like it's a space, it's a storage, it's a building type, right? Where we can store many virtual machines. Okay, what are subnets? Subnets are logical division of IP address. Like it defines the range. Like subnet, there are public subnets and private subnets. So it So it gives it defines the IP address like from suppose 10.0.0.10/16. So it defines a range like from here to from this to this range. All the IPs will be public and all the will be private. You can understand, right? And there is internet gateway. Our public subnets passes through the internet gateways, and our private suppose if there is a private gateway, it isn't assign any public IP, right? Then how it gonna connect to the internet? Like we will be creating our model. So we don't want anyone would come to our model and keep on invoking it, keep on increasing our bills. We don't want that, right? So we are gonna place it in a virtual machine that is private, but we are want to download the model, right? We want to install the transformer and everything. So how we are gonna do that? So we can rent the net gateway, we can buy the rent net gateway, and we can use it to get our things. It's like it a bit outbound, it gives a outbound network, like we can send request to the internet. Via it we will give the request to net gateway, and it will send our request to internet. It will get the response back. It will again then give our response back to us. And yeah, that's how it works. But again yeah, one more thing, like net gateway can't anyone can't like come to net gateway and like enter. No, it's like Darban, it won't give you entry to it inside, like yeah. And but in net gateway, it's an inbound access and outbound access. Anyone can come in, anyone can anyone can send request. We want that, right? If we close the doors, then how anyone would, like user, how they are gonna send request to us, right? Or send our request, yeah, like messages and everything. Okay, so let's move to the route tables. So what are the route tables? Route tables are basically, it controls the direction of traffic, like where the subnets will go. Like suppose there is a this virtual machine like model, so it will say that this is our IP. We are in a private subnet, so where would I would go? So we will define it there, like go to the NAT gateway. If you don't define it here, then where would it will keep on stumbling here and there, and request would never, we would never get the internet access. I had did the mistake. I had messed up the route tables, and then I wasn't getting the internet, so I had to create it once again. Actually, what I had done is I had created at multiple VCs. I have created one VPC and I have created another VPC and put both of the virtual machines in that one. But route tables and network, all these configuration I have done for the other tables. So this messed up the system. Like I wanted to connect it to from here, but it's not connecting because I have I it took me a lot of time. Like it took me 1.5 days approximately to debug it because there was power outage. So it took me a few hours, but I'm telling you the exact number. So, but security, let's add security groups. What are security groups? Firewall rules. Like suppose our we said like this is our like we want to SSH in our system. Like suppose we can provide security, like we can create the password and everything so that nobody or and no one like can put come here and do whatever they want, like run our model. So we want to provide it. Like suppose our password got leaked, we are seeing that our password is getting leaked again. Let's suppose we have pushed our password, we forgot to put it in the git, and our password got pushed in the GitHub, and GitHub got all credential got leaked. As we have already seen recently, all of the credential had got leaked. Actually, we don't need any thing to get leaked. If we put it in the our credential in the GitHub, anyone can copy it, right? Yeah. So for that purpose only, we are have an additional security firewall. So it will block the IP, or it will define the rule that what IPs are allowed. Like for our for SSHing into our public like API virtual machine, we can put that only our IP can have the access to to get into here, so no other person from their laptop or PC can enter our API virtual machine. And Inference virtual machine, how can we enter in our Inference virtual machine if it don't have any public IP? So we can use, we will first go to the API virtual machine, then would enter Inference virtual machine. Like we can do that, right? We can't enter here directly, but we can use the Bastion jump. So first we will enter here, then we will enter here. I have done this multiple times during when I was trying out all this in AWS. So yeah, let's move forward. Let's we talk about security access. Yeah, we have already talked about this. So one more question probably, yeah, I have already, user would pass through the internet gateway API call. We have already talked about this one, nothing new. So what else we are left with? Yeah, we haven't talked about the system D. What are the system D? System D are like a program which say which suppose when we enter in the AWS, when it starts our program, it after a few second or minute, it gets exited. uh, it gets exited like anytime without, like it gets time out, right? But we want our process keep on running for hours, right? So for that we can use system which will restart our process again and again whenever they want, however they want it, or we can freeze the process. Like we can also use tmux. I was using tmux by using which we are persisting our connection. Our process was not really like detached mode. Like there we, if you heard about the Docker, we played it, we run our images, and then we put it in the detached mode by using dash d. Like we don't we want to run play with our terminal, right? We don't want in a terminal our processes keep on running. Our processes keep on running, we want it to get detached, right? So that we can do our extra work. Of course, I know we can create another terminal, but it still, when one terminal is open, then it consumes a bit RAM, right? Of course, when the Docker is running in detail, it also consumes RAM. But I hope you understand it. You can listen. And other thing is the persistence what we are getting from the tmux or systemd, or there are other ones also. So what else should we talk about? Let's see. This is our assignment what we had got. We talk about all these. Yeah, this model was given for our work. Okay, so yeah, so let's see. Yeah, we talk about all these components, security group to we talk about all this VM design, then networking design, infrastructure, edge code. We can you can see this is a structure of Terraform. We can run the Terraform using these commands. After that, you also these are the IP side bot. I after doing the run. Between these, you need to configure the AWS. You can Google it. How to configure AWS or GCP. You can use different cloud providers. I haven't put it here, and of course I can't put it here. I could have just included like a question mark or anything like that, because I needed to put my credentials. Is not any big steps to do here. You can see, yeah, was the screen I had got after doing the Terraform apply. Okay, after doing our another VPC route table, subnets, and everything was created in our virtual machine. One more thing I want to tell you, like what would be the flow? How do the things we are gonna create? Like, yeah. So first we will be creating the VPC, then the subnet, then the route tables. Why we not, right? One can't exist before the other has existed. We can't create a subnet when BPC is not there. Where we are gonna create, like you can see where we are gonna create subnet if where we are gonna create subnet if we don't have the VPC itself, like we need this container, right? So that's how. So then we will create these two subnets. Okay. Then we will create the route tables, and then we will create gateways, internet gateway, net gateway, and then we will create a virtual machine at the last when everything is completed, because virtual machines are the last, yeah, last to get connected in this infrastructure. Okay, so these are the deployment configuration we can do for the system deal. You can use these are the command we can. If you use Linux, you must have used these commands on your day-to-day basis. We do it, right? You can see they are using the same I for the invocation deployment steps. If you uh, it's not gonna, so first you need to clone this repo, and then of course in the API virtual machine you need to download this bun, also source it, because, or you need to restart the terminal, then install the III engine, then we can install, get inside the color. Okay, then install the, let's not talk about this all much. You also get to install one more thing, I think, this is yeah, git. We forgot to install git, right? Yeah, I think we forgot to install git. Yeah. We also need to install git before that. Okay, and API endpoint is you can use, you can change the content as per you. One more thing I want to tell you about that, when I was using the gamma model, it was giving tech campus like what is red, explain Redis in simple words. So it was giving like a Redis something and something, but it was not as good as ChatGPT. Like it gives very nice content, right? But it was not giving that because the model is very small. I think, I don't think it was trained with lots of parameter. Its size was 270 MB. Okay, so yeah, you can read all this if you want. RPC company. I have also written here what were the challenges I faced. Like we were not able to SSH into the that one private one, because I was needed to do Bastion jump, which I learned in the process. Same I have done some of here by use. I have used AI give a to beautify it, but I think it has written in a very deep English. I think I had given it a plain one. Okay. Storage constraint was there too. Like when I was trying to install the uh, PyTorch, our storage was filling because it was doing it in the slash temp. So what I did, I created the virtual environment and then I installed it there. So do remember to do that too. And I have also increased its volume. I was given 30 GB for no, free tier. So I used the 8 GB for the API worker, and I have increased this from 8 GB to 20 GB by using some commands to increase the. Of course, I have googled that commands and it worked really well. Okay, some memory constraints was there too, like our uh, model was facing some difficulties to run in the environment for the 1 GB RAM environment. Like, of course, would and it had eaten all of the RAM and whatever 1 GB RAM give. Did I talk about this too earlier? Like, if we had put the API worker and the Python worker, both of them in a simple machine, like I created one EC2 instance, then how they would have gone to manage this? Like the API worker, and it had consumed some of the memory, and then we are left with bit more less memory. So that was also the problem. So what I did, I created what I created swap, like I created swap, right, in that one. Okay, I created the swap file that I can show you from my system too. You can see there is a swap variable I am using ADB, so I had created similarly on the that one for on that one for 4 GB swap. So it was a bit slow, but it was using that one for storing, like how the swap works, like when the if you have studied the computer architecture, you know about the low L1, L2, L3, L4. So basically current so our current programs use here, and all the last ones by using the one was pushed into the swap, like works bit up like that. Okay, so I used yeah, API routing, yeah, these two end to end. I was facing this issue because I had not created, I have not put the III URL, exported the III URL for the WebSockets, and I was trying to connect in the WebSocket in the other one. So I had very huge time debugging that. I needed to export it like multiple times. Then I got but when I was exporting in one, it was exiting on the other. So I had to use the tmux. I was forgetting it was lots of tests and work that time. Anyways, let's move into an interface. Yeah, trade-offs, lots of trade-offs. Let's move ahead to the screenshots. Let's talk about this one uh, a bit. This one from Terraform, after it got completed, I mean, AWS got configured, our EC2 instances, and our bill started to incurring. And then there is VPC and subnets with a VP. Yeah, you can see the VPC here is the this is the network SQL, this is the main route table, and you can see a structures to subnet route table, and there is gateways to which didn't come into the image. You can see this is the image of the subnets that these two are using. You can see we are using these two for this VPC. These are the EC2 instances we are running. You can see from here the security groups related to the VPC. You can see here. Okay, you can see. Okay, then we can see here worker when it got registered, API got invoked. It was first giving gateway timeout because we know it would take a lot of time to process it. So then I increased its waiting time. It was first 30 seconds, so I increased it to 3 minutes, 5 seconds, then got some response. I was already getting response in the local environment, so I can show you. Okay, it's a model prompt execution. Whenever we were giving, we were passing the as I have told you, like we had talked about this in the beginning of this video, like when the user gives the request, it goes to the API worker, HTTP translates it into the RPC, then RPC is passed to the inference worker, then it got to the model has got here, and then it passed to this. After that, what we see here, and these are the technologies. You can see what all I have used. And suppose we want to 100x, these were the things that I had suggested, like production hardening and scaling. There's lots of we can use the CI/CD pipelines and all, and how we are gonna what we are gonna do if it's 100x larger, we scale it, and we are gonna balance it using load balancer and all that. I have written some of and asked some of it from ChatGPT. You can do we can use auto scaling groups, ASGs, or anything else. We can also use GPU dedicated, but it costs a lot of money. Yeah, of course we can buy, if you have money you can buy bigger ones, of course. And all this too, I think this is it. What should more should I say? I think this is it. Okay, so let's end this video here. Thanks for watching.